Today we're talking about function transformations. This is actually a wrap-up of our functions transformation learning activity, so you should have done that before watching the video. Hopefully this will just bring all the loose ends together. So the first kind of transformation that we want to talk about is horizontal translations. If we start with a graph of y equals f of x for any function f, and subtract a number h from the input. So that means our new function is going to be f of x minus h, subtracted from the that's what we mean by subtracting it from the input. So that results in a horizontal shift h units to the right. If we add a positive number to the input, then we're going to shift that many units to the left. So let's look at some examples here. Here is my mystery function, and the one in dark gray is y equals f of x. The blue one is y equals f of x minus 4. So it has been shifted 4 units to the right. Over here we have the graph of f of x plus 5, and that has been shifted 5 units to the left. Next, let's look at vertical translations. So again, we're going to start with the graph of y equals f of x for any function f. This time we're going to add a number k to the output. So instead of adding something to where the x is, you're going to add that number to the outside, to the result. And so we'll get f of x plus k outside of the parentheses this time. That results in a vertical shift k units up. If we subtract k, then we shift down k units. So let's look at some examples here. We have the same mystery function. Here it is shifted 7 units up. You can see from the equation this is f of x plus 7. Down here we have f of x minus 3. Both times we have added and subtracted this number to the output. It's outside the parentheses. And so we get the vertical shift either up or down. The next kind of transformation I want to talk about are reflections. So again, we're going to start with the graph of y equals f of x. And then we're going to take the opposite of f of x. So negative f of x results in a reflection over the x-axis. And if we take the opposite of the input, f of negative x, that results in a reflection over the y-axis. So let's look at some pictures here to see what that means. So you can see it's our same original mystery function, and reflecting over the x-axis, well, the negative f of x reflects over the x-axis. So I have a mirror image where my mirror is my x-axis. Over here we also have a mirror image, except this time the mirror is the y-axis when the function is f of negative x. Your activity allowed you to play with y equals negative f of x by setting the value of a to -1. And this one wasn't part of the activity, but we do want to be able to reflect over the y-axis from time to time. The final kind of transformation that I want to talk about are vertical stretches and shrinks. Again, we're going to start with the graph of y equals f of x, and this time we'll also take a positive number a. We want to consider what the graph of a times f of x looks like. It's going to result in either a vertical stretch or a vertical shrink, and what this will depend on is the value of a, whether a, what a is. It's got to be a positive number. If it's between 0 and 1, then you get a vertical shrink. Any positive number less than 1 as your a will give you a vertical shrink. Any positive number greater than 1 will give you a vertical stretch. So let's look at some examples. So here's our same old mystery function. So you can tell the peaks here are twice as tall as they used to be. Here is my stretched out function y equals 2 times f of x. So twice as tall in the positive direction, twice as, I guess, deep would be one way to describe it when you're going in the negative direction. And when I've got a number less than 1, when I have 1/2 as my number, everything is shrunk down. It's half as tall. And you can hear my baby playing in the background. Happy baby sounds. Sorry for that distraction. I don't have time to re-record this. So this is the end of our vertical stretches and shrinks. Play with the activity to get an idea of how these transformations work when you have more than one going at the same time. And that is it for function transformations.